Welcome to another edition of RCE. Again, this is Brock Palen. You can find us online at rce-cast.com. You can find an RSS feed, links to your favorite podcast feeder, as well as the entire back catalog. We've been reached out to by a couple people saying we'd love to have the entire catalog in iTunes. It appears we are unable to do that, so only the last couple of episodes are there. So if you want to look at our entire back catalog, visit the website. You can find everything there. I have again with me here Jeff Squyres from Cisco Systems and one of the authors of OpenMPI. Jeff, thanks a lot for your time.
Hey, Brock. Welcome to February. It's a cold month, but we've got some interesting stuff to talk about.
Yeah, we've got another one of those polar vortex things I see them talking about in the news. I don't think anybody in Michigan ever takes them seriously anymore when they talk about those things because it's like, it's Michigan, it's cold, get over it.
Yeah, but you got something coming up in March.
Yeah, so in March, I'm going to be down to the University of Illinois at the ARCC, known as the Advanced Research Computing on Campuses. It's more of a workshop. It's a small gathering of really HPC center, normally on campus, so smaller centers, not like national centers, but the NCSA does help us out with this as one of the hosts. Kind of talk about business models, best practices, condo model, allocation models, what vendors you work with, and things like that. So that is March 22nd through 24th. There's a set of tutorials at the beginning, so if you want to learn about high throughput computing, business models, other things, there's a couple of tutorials, as well as the regular conference. So full disclaimer,
so the whole thing
I am one of the organizers.
Is getting ready and getting started with HPC at your organization. Is that kind of the theme?
Yeah, that, and also if you're looking at, making an investment in your institution and you want to look really hard about what's the most effective way to impact the most number of faculty and research projects, just to, really stretch the amount of output for your investment and things like that. So it's a good gathering of people. I will be there. I hope to see others there. If you see me there, be sure to say you like the show. Every bit of encouragement I hear gives me more onus to keep this thing going.
It's helpful, yes.
Yes, it is
All right,
helpful.
well, what are we talking about today?
So today we are going to be talking about EasyBuild. Our guest today is Ken Hoste. Ken, why don't you take a moment to introduce yourself?
Hi, Brock. Hi, Jeff. So I'm Kenneth Hoste. I'm a member of the HPC support team at Ghent University in Belgium. I have a master's and a Ph.D. In computer science as well from Ghent University. And at the HPC team, I'm mostly responsible for user support and training. And as a part of that, I also work on EasyBuild.
So a little side fact here, you said in Belgium, my boss, Dr. Eric McKeelson, who's our Associate Vice President for Advanced Research Computing, is Belgian. And his wife is too.
Okay.
And he's from there. So I don't know if it's the same institution where he went. I know he did his postdoc at Illinois, but I don't know where he did his actual pre-work. So I'm going to have to check on that. Might be a little bit of common information here. So
okay.
I looked him up on LinkedIn, man.
Yeah, for sure. So why don't you give us a little bit of overview? What exactly is EasyBuild?
So EasyBuild is a framework implemented in Python, and it intends to make it very easy for people to compile and install scientific software on HPC systems.
So where does it sit in this realm of, is it something like CMake and AutoComp, or is it like modules? Is it somewhere in between? Kind of where does it sit in this stack?
So it's certainly not a replacement to CMake or any of those tools, and actually it basically wraps around existing build systems. So it's like a layer on top. And in terms of modules, it also leverages modules itself. So it talks to the modules tool and just gets all the information from it as well. So it basically wraps around all these things. It is the layer on top.
So now, what do you mean by that, by being a layer on top? It uses all of the, well, how does this tie together with scientific software, I guess, bring it together?
So let's say you have a scientific software package that you install in a particular way, for example, CMake, make, install. So you follow the steps in the documentation to do this. What EasyBuild will actually do is automate this whole process for you. So if you're installing, let's say, Petsy, it knows that it's supposed to call CMake and then make afterwards and then make install after that. So rather than replacing any of the build systems that the software is using, it just automates the whole procedure.
Now, do you do that with, say, recipes per se? Are there built-in rules into EasyBuild saying, like I say, EasyBuild Petsy, and it says, oh, let me go look up the Petsy recipe. Here's what I do for Petsy.
Yes, exactly. So what it does, so you have the EasyBuild framework itself provides all the supporting functionality to do all this stuff, like run commands and generate files and all these kind of things. And then basically you have a small Python module or almost a Python script on the side, which basically tells EasyBuild what to do, like call CMake, call make install, go there, change that file, things like that.
Now, do you have to kind of make a plugin for every build system? So like if you cover CMake and AutoComp, you cover a lot of them, but you get into things like OpenFOAM, and it's got its own build system, and VASP, which basically just has a makefile, edit it at your, threat of death, just, can it handle those sorts of things where you practically are having to patch makefiles or things like that?
No, it does handle all of these things. So the framework itself is basically not specific in any way to any build system. But we do include plugins, or we call them easy blocks, in the EasyBuild release that cover stuff like configure make, cover stuff like CMake. We have one for OpenFOAM and other that I like to call nasty scientific software like WRF or CP2K, for example. So the easy blocks that we include in the EasyBuild release know how to do all of these. And you can implement your own on the side and just give them to EasyBuild, and it picks them up when it needs to.
Okay, so these blocks, are they like helpers, or are they basically the entire community's accumulated knowledge of the options for OpenMPI, the options for CP2K, and those get committed as part of the project, and anybody who downloads it gains from that shared knowledge?
Yeah, that's basically what it is. So it basically defines how you install, let's say, OpenFOAM, and what all the nasty tricks are that you have to do to make it right and make it perform well and so on. So it's basically like an expert system. And everybody that contributes to EasyBuild helps out a little bit, and in the end you do the right thing automatically.
So how does it handle dependencies? So say I want to install, for example, something I'm quite familiar with, OpenMPI, but I also need to have, say, the verbs library or the libfabric library or the whatever library installed before I install OpenMPI. How are those things tracked?
So there's actually another component to EasyBuild. So the easy block is a Python script, let's say, that defines the build procedure. When you want to install a particular version of a particular software package, you give it a small specification file, which we call easyconfig files, which basically tells EasyBuild install OpenMPI version 188 with this GCC compiler. And then EasyBuild takes that information and goes ahead and performs the build procedure for OpenMPI. One of the other things that is specified in there is the list of dependencies together with the versions. So EasyBuild knows which dependencies should be there, and if they are missing, or if the modules for them are missing, it will go ahead and build those first together with the module file, and then go back to OpenMPI and build that on top.
So why is this better than just a bunch of bash scripts? I mean, for most of my applications, I kind of build a bash script, I leave it in the install location, and I can rerun it anytime I need to kind of reinstall that package. Because say, libmverbs went away for some strange reason in the last verbs update, and I need to rebuild everything. Why is this superior to that?
So there's, let's see. The reason we didn't go with bash as a, let's say, implementation language is because it's a scripting language, and it gets ugly really fast if you want to do big, complex things in it. There are other build tools or package managers, if you will, out there that have picked bash and have stuck to it. Like Gentoo Prefix is still using bash. But if you take a look what they are doing, they're doing object orientation in some way in bash scripts, which